All right, so today we're going to do 3.3 factored form notes. And again, it's kind of a review of what we did in 3.1 and a little bit in 3.2 in graphing. Steps when we're graphing from factored form is we first need to determine if it's going to face up or down. So remember that in order to figure that out, we're looking at the A value. Okay, so looking for sign of the A value. And usually if it's in factored form, the A value is out in front. So usually factored form is going to look like y is equal to A, and that's going to be like x minus a number. And I'm just going to call it, what do I want to call it? X minus, we'll say x minus B and x minus C. Okay, so B and C are going to be values. So it's going to look something like that. So we're going to look for the sign of the A value, and remember that if it goes up, so if A is positive, then it's going to go up. If A is negative, it's going to go down. The next thing you're going to do is we're going to find the zeros or x-intercepts. So whether that means we factor and then solve, or whether it's already set up to do that. All right, so that means that we're going to go x minus B equals 0, x minus C equals 0, and we're just going to solve that for our values. So remember, with that, we would add B to both sides, so x is equal to B. We would add C to both sides, x is equal to C, and then remember our points are like B0 and C0. And remember, B and C are numbers, okay? And then we're going to mark those or graph them on the graph, okay? So we're going to see if it goes up or down. We're going to solve for our x-intercepts. We're going to graph them, okay? That's what this means right here. And then we're going to find the y-intercept by changing from factored form to standard form by multiplying. And so in this step, that means we're going to take our factors and we're going to multiply it back out. So we're going to say this is x and minus b, and this is x and minus c, and we're going to find it and change it back to standard form. So in this case, we would have like x squared, negative bx, negative cx, and positive bc, whatever our numbers happen to be. All right, so we're going to put it back in standard form to find the y-intercept, because we want it to look like this. Y is equal to ax squared plus bx plus c. All right, and so we're looking for what this c value is at the very end. So this is what we care about. And then it wants us to find the axis of symmetry on the vertex. And again, that's going to be the h is equal to negative b over 2a. And remember, we solve the k by plugging in the h. All right, and so then that's going to give us our vertex. So again, find x-intercepts, change it to standard form, do vertex, and then we connect them on the graph. All right, so again, this is our HK value once we find it. And so we want our HK value, we want our y-intercept, and then we want our x-intercepts. All right. So those are the things that we're looking for if we're going into factored form. And then just again, always remember that this is a smooth curve. It's not straight lines. So we're always wanting it to make it into like a U shape. So it says for the first example, let's get going on it. So it says the direction of the opening. So that's the first step. Does it open up or down? There's not an A value in front. So that means there's really a 1. So it's going to open up. We're going to solve these. So this would be x minus 1 equals 0 and x plus 3 equals 0. And so when we solve that, we've got add 1 to both sides. So x equals 1. We're going to subtract 3 from both sides. So x equals negative 3. So those are our x-intercepts or our zeros. So that's the point 1, 0 and negative 3, 0. And then from there, we want to figure out what our equation looks like in standard form. And so in standard form, we're going to do our box because that's going to help us find our y-intercept. And so we're going to multiply. So x times x is x squared. X times -1, -1x. 3 times x, 3x. 3 times -1, -3. And notice that there's not an a value. So when I combine these, this gives me x squared. These two I can add. 3x and -1x is positive 2x. And then -3 is at the end. So my equation in standard form looks like that. And so then from there, I can find my vertex. So again, our vertex point is going to be h is equal to -b over 2 times a. So we get -2 over 2, which is -1. And then when we plug it into our equation, we've got everywhere there's an x, we're going to put in the value that we got, which in this case is -1. So I'm going to go -1 here, -1 here. And again, you can either put it in your calculator or just do it out. -1 squared is +1. 2 times -1, -2, minus 3. And so if I plug that in, or if I just do the math, I go 1 minus 2 is -1. -1 minus 3 is -4. So that means my vertex point is going to be -1, -4. And then it says, is it a max or a min? We know it's a max or min by if it faces up or down. So remember, if it faces up, it's a minimum point. And then our axis of symmetry is our x value of our vertex. And when we solve, we know our y-intercept is our c value. So our y-intercept is going to be the point 0, -3. And then we're going to do domain and range. And again, domain for a parabola is always -infinity to infinity for interval notation, or all real numbers for set notation. And our range, I like to just wait for just a minute until you graph it. So as we go to graph, remember we're going to graph all of those pieces. So our axis of symmetry is -1. So I'm just going to do that really quick while I have the pink pen. All right, and then we're going to graph the rest. And so our vertex is -1, -4. And so that's this part. We're graphing our vertex. And we've already graphed our axis of symmetry. Our zeros are at 1, 0, and at -3, 0. Notice how that's 2 spaces away from the dashed line and 2 spaces away from the dashed line on both sides. So we've got our zeros graphed, and then our y-intercept is 0, -3. Notice that's 1 space away, so we're going to do a dot on the other side that's 1 space away. And then we're just going to connect, and we connect it with a curved line. All right, and I know that's going to just take some time. Just do the best you can. Okay, trying to make it so it's not straight lines. And then our range is the lowest point, which is our -4, and then it goes up from there. So our lowest y point is -4, and then our y's don't ever end. So we're going to go from -4 up to infinity. All right. Trying to say, if we stop there, just keep going. We'll just keep going. All right. So for this one, factored form, we need to factor it. And so notice that it's given to us in standard form, which is nice in some ways because that helps us with the rest. But if we're trying to find the zeros, we have to factor. And so to factor it, remember, we just do the box. And so we're going to go a times c. So 1 times 3 is 3. Factors of 3 are only 1 and 3, and I'm trying to get 4 in the middle, and that happens to work out perfect for us. So we've got x squared. So first term goes in the first box. last term goes in the last box, and the pair that we picked goes in the other two boxes. So we've got 1x and 3x. And then we're going to take out greatest common factor. So greatest common factor out of the first row is an x. Greatest common factor out of the second row is a 3. Greatest common factor of the first column is an x. Greatest common factor of the second column is a 1. And so we're going to go x plus 3, x plus 1. And so now we have our factored form. And so if I want to know what the zeros are, then I have to set those equal to 0. And again, zeros or x-intercepts, however you want to say it, it's the same thing. So we subtract 3 from both sides, so we get x equals negative 3. So when we look at our zeros, we've got negative 3, 0. And then negative 1, or we subtract 1 from both sides because it's plus, and so we get x equals negative 1. And so we've got negative 1, 0. And then the direction of opening as we go up, back up here, direction of opening, A is positive, so it's going to go up. And then we're going to find our vertex. So h is equal to negative b over 2a. So we're going to go negative 4 over 2 times 1. So that's negative 4 over 2, or negative 2. And then when we go to plug it in, our k value is going to be something squared plus 4 times something plus 3. And the something that we're plugging in is going to be that negative 2. So negative 2 squared is 4. 4 times negative 2 is negative 8, and then plus 3. So as we do that, whether we do that in our calculator or not, 4 minus 8 is negative 4, and negative 4 plus 3 is negative 1. So our vertex then is negative 2, negative 1. It asks if it's a max or a min. Remember that if it faces up, then it's always a min. And then our axis of symmetry is going to be x is equal to negative 2. And then we know our y-intercept because it's already in standard form from the beginning. So our y-intercept is the point 0, 3. Domain negative infinity to infinity, or all real numbers. And then our range, I always like to graph first, but you know your range at this point without graphing, or we could know our range. Our axis of symmetry is at negative 2, so I usually like to graph that first. Okay, so we've done that. We're going to graph our x, well, we can graph whatever. We're going to graph our vertex, which is at negative 2, negative 1. So we've graphed our vertex. Our zeros are at negative 3, 0, and at negative 1, 0. So notice how they're both one space away from our axis of symmetry. And then we have a y-intercept at 0, 3. Notice how that's 2 spaces away. So we'll go 2 spaces away on the other side. And that's our y-intercept. And now we're going to connect with a curved line. My first one wasn't as great, but again, just do the best you can. I always just make my dots a little bit bigger if it doesn't hit. And then our range then is going to be our lowest point, which happens to be negative 1, up to infinity because it doesn't end. Or we would have y is greater than or equal to negative 1 for set notation. All right, and let's look at our last one. Oh, yeah, that's our last one. All right, so with this one, we're going to factor it. When we factor this one, remember when I factor, my first step is always to take out the greatest common factor. So I'm going to take out a negative 2 as my first step. And so that's going to give me x squared minus 6x plus 8. And then I'm going to go 1 times 8 is 8. My factors of 8 are 1 and 8, 2 and 4. And we're trying to get negative 6. And so we're going to have both of those be negative. And then we're going to factor. Now the reason, hopefully you've kind of noticed that a lot of times our numbers are going to be semi-similar. just for the fact that we're trying to keep our numbers smaller so that you can actually graph them. So I know you're like, we always have the same. Sorry, you might always think we're having the same equation, but it's just because we're trying to make it so it fits on a graph nice for you. So this is negative 2x and negative 4x. We're going to take out our greatest common factor, which is x, greatest common factor, negative 4, greatest common factor, x, greatest common factor, negative 2. If you want to check that, remember we can. X times x is x squared, x times negative 2, negative 2x. Negative 4 times x is negative 4x, and negative 4 times negative 2 is positive 8. So with that negative 2 is going to be out in front still because that's part of your solution. And then it's going to be x minus 2 and x minus 4. All right. The direction of opening, because of the negative 2, is going to go down. And because it goes down, that means we have a maximum point. So we can kind of answer those two questions at the same time. To find our vertex, we're going to go h is equal to negative b over 2a. So remember that going back to standard form, there's our a, b, and c. So we're going to go negative 12 over 2 times negative 2. So you've got negative 12 over negative 4, which is 3. And then we're going to take that and plug it back into our equation to find k. So it's going to go negative 2 times something squared plus 12 times something minus 16. And remember that something is what we got for h. So we're putting 3 in here. And then we're just going to do the math. And again, we can plug that in the calculator or we can do it out. Sometimes I think it's easier just to plug it into the calculator. Sometimes I think it's easier just to do it out. But remember, when I put it in the calculator, the key to the calculator is you have to put the parentheses in. So you've got negative 2, parentheses, 3. Remember that we want to close it. And that's why, for me, sometimes it's easier just to do the math and not put it in the calculator. I think it takes longer. This one I probably would put in the calculator because it's a little bit bigger. And so we get 2. So we just put it in. It spits out an answer for us. We get k is equal to 2. And so that makes our vertex point be 3, 2. And then our axis of symmetry would be x equals 3. We already have our zeros. Actually, we don't have our zeros. We're going to take our factors, which are x minus 2 equals 0 and x minus 4 equals 0, and we'll solve. I forgot we didn't do that up top. So we'll add 2 to both sides. We get x equals 2. So that means our first 0 is at 2, 0, and then it's minusing 4. So we'll add 4. And so we'll get x equals 4, and our point is 4, 0. And so with that, I know we're going to the next page, but our y-intercept, I don't know if it's on your next page. I think it's all on the same page. Our y-intercept, I'll just write it down here. Our y-intercept is going to be the point 0, negative 16, which is not on our grid. So just be aware of that. Our domain is negative infinity to infinity, or all real numbers. And then our range we're going to look for. So we're going to graph those points. I'm going to graph the axis of symmetry first, which is at 3. All right. So we've got our axis of symmetry at 3. So we graphed that. We're going to graph our vertex at 3, 2, which is here. So we've got that. And then we've got zeros at 2, 0. And we have one at 4, 0. And we've graphed that. Now, my y-intercept, because it's so far off my chart, I would probably not graph it because you really only need 3 points to graph. And so I would just know that it's going to come clear down here. I mean, it's going to be really steep. In fact, this is probably, it's more like this. It's going to cross somewhere down here. But our range then, our highest point is 2. And so it's basically going from negative infinity to 2. Whoops. Or we're going to say it's y is less than or equal to 2 because it goes down. Either one, okay? Same thing here. I could have done all real numbers. All right, that looks like that's it for 3.3. I probably could have broken it down into 2, but we just did 1 today. So if you have questions, make sure you ask, and I will see you later. Maybe. Why will that not stop sharing? There we go.